The pace of golf activity and the traffic on golf courses is presently at a peak that has never been equaled in our country. Many of the construction methods that were satisfactory in an earlier day will no longer produce greens that will withstand the wear now imposed upon them.
These were the opening remarks made with the introduction of the first USGA specifications for a method of putting green construction in 1960. Yet today, with ever-increasing pressure for flawless turf and fast, true putting surfaces, which receive heavier play than ever before, this statement is even more true now than it was nearly 40 years ago. The truth is, though, construction methods alone cannot determine the health and performance of a putting green. Factors like light, air movement, traffic patterns, size of greens, hole locations, irrigation, and maintenance practices are all interrelated elements that, together with the construction method, determine the health and performance of the green. Scientists and USGA agronomists are continually working to develop and refine guidelines in all these areas to provide the optimum health and performance of putting greens. While there are many ways to build a putting green, the USGA has developed a set of recommendations that have proven to be the most reliable in the majority of situations. Although many critical steps come before construction begins, such as the careful selection and testing of each component, the purpose of this video is to demonstrate the recommended construction procedure, the step-by-step how-tos of building a putting green to USGA guidelines. After all materials have been carefully selected, tested, and secured, the first phase of the actual construction process involves preparing the site. A good deal of space will need to be allocated for stockpiling drain tile, irrigation components, gravel, and other building materials on the golf course. An ideal location would be central to the course, yet easily accessible by large trucks. If it's not possible to stockpile the root zone mixture on the course, it may need to be stored at the plant. Blending of the root zone components can be done either at the sand supplier's plant or at the golf course. The best choice for each individual operation depends upon a number of things. Blending on the golf course requires a lot of space, but it can eliminate one dump load operation. Blending at the sand plant generally involves dumping the blended root zone mix at a central location on the course, from which it is loaded and carried to the individual green cavities. Or, if the sand plant is nearby and trucks are available, root zone mix may be hauled directly to the green cavity from the plant. If blending is performed at the plant, it is important to complete the appropriate quality control tests before the mix is hauled to the course. By the same token, if the root zone material is being mixed at the golf course, a regular testing system is essential for preventing variations in the mix which could adversely affect an otherwise perfectly constructed green. Fill materials for the subgrade and for the surrounds also need to be acquired and stored. When preparing the area surrounding the green, it is important to use good quality topsoil and not the lower quality soil that might be used in shaping the subgrade. A new project or complete renovation begins with the architect marking off the shape and contours for the new green site. The shaper will work the soil repeatedly to form the new green site and green cavity according to the architect's design. The site is built in layers to prevent air pockets from forming that would settle later and distort the design. On a restoration project, stakes are installed to establish the shape of the surface, and then the old green material is cored out. The stakes are kept intact so that the green can be rebuilt as closely as possible to its original contours. This site has used an unusually extensive staking and measuring system, on a special case where the greens are being reconstructed to match the original architect's drawings. Whether a new construction, renovation, or a restoration project, and no matter how a green is staked, the construction method is generally the same. Success begins with a proper foundation, the subgrade. Subgrade preparation is often the most challenging step of the green construction process. This step separates the best builders from the rest. The subgrade soil is often high in clay, and its moisture content can vary widely during the shaping process, especially when it rains. But when it's done, a good quality subgrade will provide a firm, stable base that conforms closely to what the finished grade will be. If laboratory testing indicates an intermediate layer is needed between the root zone mix and the gravel layer, the subgrade should be 18 to 20 inches below the surface. If no intermediate layer has been specified, the subgrade should be approximately 16 inches below the surface. The shaping of the subgrade is typically done with track equipment, the most common ranging from a D4 to a D8, depending on the amount of dirt and rock to be removed. The excavated root zone mix sometimes can be put to good use on tees or on the area surrounding the new green. The base should be free of large chunks of debris or stone, with a smooth, even finish to ensure that excess water will flow to the drain tiles. Make sure the surface is free of hollows that could form troublesome water collection points. Once the subgrade is fully shaped, it should be compacted to prevent settling and form a stable foundation. If the soil is exceptionally dry and unstable, it may require a light wetting to facilitate compacting. The walls of the subgrade cavity should also be stable and compacted. They can be either vertical or slightly sloped. In rare instances, if the soil is unstable, such as with an expanding clay, sand, or muck soil, a geotextile fabric may be installed over the subgrade after the drainage trenches are dug to prevent gravel from working its way into the subgrade. The fabric goes under the drain tiles. Before moving on, the finished subgrade should be inspected and approved by the architect and other designated authorities, usually the superintendent and a course representative. The next phase is the installation of drainage lines. The drain tile system, combined with the gravel layer that covers it, will provide for rapid removal of drainage water from the green cavity. Although a herringbone design is often depicted, drain line design can vary widely from green to green. A pattern should be designed so that the main line is placed along the line of maximum fall, the path that water would naturally flow into, and lateral lines should run across the slope to intercept water moving down the slope, carrying it to the main line. Lateral lines should extend all the way to the perimeter of the green cavity and should be spaced not more than 15 feet apart. At the low end of the green, where the main line will exit, a smile drain should be installed along the perimeter all the way up to where it meets the first set of laterals, to ensure that water does not accumulate against the cavity wall. In addition, a smile drain should be installed wherever water would otherwise accumulate at the cavity wall. Drain line design is part science, part instinct. Look for low-lying areas where water might collect, and make sure drain lines are provided in those areas. When determining where to direct disposal of drainage waters, select an out-of-play area that will comply with laws regulating disposal of drainage water. To protect the terminal point from blockage or damage, it is best to end the line in a valve box or gravel sump. When selecting drainage pipe, perforated PVC and corrugated plastic are the recommended materials. They are commonly available, easy to install, and will provide a long, low-maintenance life. Drainage trenches, 6 inches wide and a minimum of 8 inches deep, should be cut along the painted lines. Generally, a trencher is used for digging drainage trenches, although in some rare instances, hand digging may be specified. The trencher operator should take care as each new trench is dug to avoid damaging the trenches already completed. It is best to remove the spoil from the cavity. The bottom of the trenches should be made smooth and clean, with no large clumps that could cause drain lines to buckle. Use a transit to check that all drain lines will empty and have the proper amount of fall. If desired, a small amount of gravel can be placed on the bottom of the trench to help create a smooth base for the drain line. Drain pipe is cut and fitted together to create the proper length for each drain line and is carefully placed on the gravel bed in the center of the trench. If PVC drain pipe is used, make sure the holes face down. More gravel can be added if needed to assure a minimum positive slope of 0.5% along the entire run of drainage lines. Once all drain lines are installed, a tracking wire can be laid in each drainage trench for locating drain lines at a future date. Next, the trenches are carefully filled with gravel, taking special care not to disturb drain lines and connections, and not to drive over any drainage work, which could crush the drain lines and necessitate costly repair. As an extra precaution, cover the joints by hand to prevent risk of damage. Again, while less common, the scope of some projects may specify handwork at this stage. Once all drainage trenches are filled to level with gravel, take a picture of the drain line installation. Illustrate the exact placement of drain lines on the architect's drawings for an accurate as-built record. If used, a plastic barrier is now installed to prevent wicking of water from the root zone mix into the surrounding heavier soil, which could result in excessive dryness at the edges of the green. Perimeter location wire can be installed around the inside edge of the green cavity at this time to help locate the exact boundary of the green with a metal detector in later years. When laying gravel against a wicking barrier, backfill the outside perimeter with the surrounding soil to support the weight of the gravel. Next comes the gravel layer. The gravel layer serves several purposes. It keeps the root zone mixture out of the drain lines. It keeps salts in the subgrade from moving up into the root zone. It provides a perching effect in the root zone's profile to maintain adequate moisture for the turf, and it allows rapid movement of excess water to the drain lines. The gravel should meet USGA recommendations. Testing will determine whether the material is suitable from the standpoint of its physical characteristics and chemical stability. Also, the relationship in particle size between the gravel and the root zone mixture determines whether or not an intermediate layer is necessary, so comprehensive testing is vital. Before installing the gravel layer, the final contours must be identified. Grade stakes are carefully marked to indicate the proper depth of the gravel layer, the intermediate layer, if one is being used, and the root zone layer. The grade stakes are installed at frequent intervals to be used as a guide for installation of the layers. Stakes are shot with a transit to ensure that the architect's design is followed. The entire subgrade is then covered with a layer of clean, washed gravel that has been tested and approved for the project. Use one entrance and exit point to limit damage to a small area that can be repaired later. The gravel layer must be uniform, at least 4 inches deep, and its surface must mirror the final contours of the green to within a tolerance of plus or minus 1 inch. Gravel should be checked and approved for appropriate depth and contours against the grade stakes by the project supervisor before moving on. Next comes the intermediate layer. An intermediate layer may or may not be specified on the project, depending upon the relationship of the root zone particles to the gravel. Only laboratory testing can make this determination. On construction projects today, compatible materials are being sought out as the method of choice more and more, eliminating the need for the intermediate layer. Since the intermediate layer is somewhat difficult and costly to install, it is often determined that trucking in a higher-priced gravel that meets the compatibility requirements ultimately saves money by eliminating the costs associated with the intermediate layer. If the project does specify an intermediate layer, its purpose is to provide a barrier to prevent the root zone mix from sifting down into the gravel layer, which could interfere with proper drainage and prevent the perching of moisture in the root zone mix. Correct installation of the intermediate layer is critical to the longevity of the green. Number 1, keep the sand moist so it clings together and sits on top of the gravel instead of sifting down. Number 2, make sure it's spread to a smooth, uniform thickness of 2 to 4 inches over the entire surface, using the marks on the grade stakes as a reference point. A 4-inch depth is more expensive, but is easier to work with when spreading the material by machine. When installing the layer by hand, pushing sand between long sections of 2x2s or 2x4s laid on the gravel 6 feet apart can help a great deal. As always, take care to avoid altering the contours of the gravel or damaging the underlying drains. Check the depth of the material throughout the entire green. When properly installed, the surface of this layer, like the gravel beneath it, should mirror the contours of the final surface. Next comes the root zone mix. If you have not installed an intermediate layer, the root zone mix will go right on top of the gravel layer. By the time the root zone is ready for installation, it has gone through a stringent series of selection, testing, and processing procedures to assure compatibility with the gravel layer and to determine the need for soil amendments, such as sulfur, lime, and fertilizer. The root zone mix is spread over the entire surface to a depth of 12 inches. Whether laying it over an intermediate layer or directly onto the gravel layer, keep the mixture moist to prevent migration into the layer below and to assist in firming. The track loader actually serves a double function because as it distributes the mix, it also helps firm the root zone as it moves over the site. The vehicle should only travel over areas where the root zone mix has already been placed to prevent damaging the layers underneath. Vehicle tires should be clean when entering the green. Carrying soil, mud, or plant materials into the root zone can cause problems later on. As the mix is being distributed throughout the cavity, it should be leveled, firmed, and smoothed to conform to the surface marks on the grade stakes. The depth should be checked frequently over the entire surface. The final firming and smoothing of the root zone can be accomplished with a mechanical bunker rake or a very small tractor with a drag mat, smoothing and settling the entire surface between repeated applications of irrigation water. It may be necessary to add more mix following the firming process to ensure that the surface of the root zone matches the designated grade. And of course, the architect, the project supervisor, and the course representative will want to inspect the final surface before seeding. 1 gallon of root zone mixture, a composite of 8 to 10 samples from each green, should be collected, labeled, and stored as a reference in case future testing is needed to determine if maintenance practices, poor water quality, or other outside influences have adversely impacted the root zone over time. The samples are also an important record if a dispute should arise later on as to what material actually was installed on the green site. The installation of the irrigation system can occur almost any time during the construction process, prior to planting. Waiting until the cavity is filled will reduce the possibility of damaging irrigation components during construction. Either way, it's important that the irrigation spray patterns are configured to provide good coverage of the entire green surface. A back-to-back perimeter irrigation system will provide the control to meet the separate water requirements of the green and the surrounding grasses. And the ability to control individual heads provides greater control of the irrigation system. Before seeding, some sites require fumigation to sterilize the root zone mix. Although it is not necessary in all areas, it is recommended where nematode populations are high, where invasive weeds such as nutsedge are prevalent in the root zone mix components, or where there are heavy populations of weedy grasses. Hire a professional to handle the fumigation process. Ideally, the surrounds immediately adjacent to the green should be sodded to a minimum of 5 to 6 feet around the perimeter. This helps prevent the surrounding soil from washing onto the green surface during heavy rains. It also greatly reduces the likelihood of tracking of seed or sprigs onto the green. When sod is laid, be sure it does not disrupt the flow of surface drainage off the green. If the sod is a bit higher than the green edge, it may be necessary to add root zone mix to the green to maintain surface drainage and to keep the adjacent surfaces even. The entire grow-in process is really a separate topic in itself, but briefly, the main issues of concern are early disease control, frequent and light fertilization, and establishing a reasonable time frame between planting date and opening date to give young plants a chance to establish themselves before being subjected to the stresses of play. Following the proper installation and the proper grow-in and maintenance procedures, you should soon have a healthy stand of turf, well on its way to delivering a high-quality playing surface for many years.